Hello guys, welcome to Prof Dan Tutorials, where I make the complex simple. Today we'll be looking at differentiation of a quotient. Our previous video on product rule, function of a function, chain rule, first principle, and so on and so forth on differentiation calculus. So please kindly check them to have better understanding. Our focus today is what we call the quotient rule. So I'm going to take you through, and at the end of this video, you should be able to differentiate a function that looks like the quotient form. All right, to start with, let's say we have a variable y is equals to the fraction u over v in a fraction form where u and v are both a function of x. So directly, if we differentiate the variable y with respect to x, as quotient rule, it says what you have is you take the denominator, which is variable v, differentiate the numerator, that is u, so you differentiate u with respect to x, minus take the numerator variable, which is u, differentiate the denominator, that is v, with respect to x, and divide all by the square of the denominator, which is v squared. So this is the rule you apply, which we call the quotient rule of differentiation. But how did we arrive at this? So quickly, I'm going to put you through using the method of first principle to get this, and then we apply it. It's quite important as it's going to expand your knowledge. So proof. So to start with, we have y equals u over v. So if you have this type, applying first principle, remember the first thing we do is we make an increment to all the variables, and by that we mean for y, for example, you had an increment in y, so equals to the fraction u, make an increment to u, over v, you also make an increment to v. And here we can make this symbol that we can refer to as change in y, subject of the formula, to have u plus, let's say this is change in u, over v plus change in v minus y. And remember, we know what y is from the start, which is u over v. So by replacing that, we can have change in y equals u plus change in u divided by v plus change in v minus y, where y is u over v. So what we are trying to do here is to simplify. Simplifying further, we can make this become one single fraction by taking the LCM, v plus change in v, the denominator, and we'll be left with v into u plus change in u up minus when v divides the denominator, we'll be left with the u that is up and v plus change in v. So what we can do here is to quickly expand. If we expand by way of expansion, the v outside here will multiply everything we have inside, u and change in u, and this u will also do the same and multiply this. So by that, we can have our change in y to be equals to, and with this result, the term here vu and the term here uv is the same thing. Remember, ab is the same thing as ba. Okay, so this is plus, this is minus, so that means this can cancel out, and we will be left with change in y to be equals to v change in u minus u change in v all divided by v into v plus change in v. And so if you go through our video on the first principle, at this point, having simplified the change in y, the dependent variable, then all we can do here is we divide both sides by change in x, because our interest is to get something like this out, the y dx. So if you do that, and in the right hand side we have v change in u minus u change in v, all divided by v into v plus change in v, divided by 1 over, or divided by change in x, okay, which we can write as so what we've done at this stage is we divide both sides, the left side and the right side, by changing x. Okay, and if we write this division changing to multiplication, we have the inverse of this, which is 1 over change in x. And at this point, what it means is that everything in this numerator is affected by this change in x. So if we rewrite that, then we can have it as a change in y over change in x to be equals to the numerator v change in u minus u change in v is all affected by the change in x. So this is times 1 over change in x, all divided by v into v plus change in v, and this can become change in y over change in x equals to v change in u over change in x minus u change in v over change in x, as this change in x affects all the terms here. So all divided by v into v plus change in v. So at this stage, what are we going to do? Remember, in our video on first principle, it says you can convert this increment in y to that of x to what we call differentiation, which is dy dx. And to get this, what it means is we are going to limit we're going to limit this as change in x, this increment in x, as it tends to 0. So by so doing, we mean you're changing y over changing x. So we limit this, okay, under limit as changing x tends to 0. So what happens when this happens? As we limit this and as changing x tends to 0, changing y over changing x becomes dy dx. And also changing u over changing x, changing u over changing x becomes dy dx. The same thing, changing v over changing x becomes the v dx. And v plus changing v also tends to become v. So applying that, it means that dy dx now becomes v, this variable. Then we have the u dx minus u dv dx over v into the all of this as tends to v. So finally dy dx becomes v du dx minus u dv dx, all divided by v times v squared. So this is the quotient rule, the formula, so to say, that you apply to differentiating anything that looks in this form, u over v. Alright guys, so quickly we're going to look at just one example, and for better understanding. So we have this question, y equals 2x minus 1 all over x minus 1 all squared, and we are asked to differentiate these, that is, look for the y dx. Okay, so of course you can't use product rule. You look at the best method to use, and this is quotient because it looks like the form y equals u over v in a fractional form. Okay, so by equivalency, that means we can say u, let u be equals to what we have on top here, so which is 2x minus 1, and our v is the denominator, and that is x minus 1 all squared. Okay, so of course in the formula we just derived for differentiation of quotient, we need to differentiate u with respect to x, and if you apply the general rule of differentiation, if you differentiate 2x, it's going to give you 2, and 1 is a constant, it gives you 0. So we have 2, and also we differentiate v with respect to x, and this is function of a function, or what we call chain rule. Check our previous video on that for better understanding. And I also did tell you in that video that you can differentiate this straight away without strictly applying the procedure or function of a function. And to do that, what you do is the power here is to drop the power. So I have 2, differentiate what you have inside the bracket, x. If I differentiate x, it gives me 1, and I differentiate this one is a constant, that is 0, so the result is 1. And we write the old function variable again, which is x, the old term, which is x minus 1, subtracting 1 from the power. So if you apply the procedure or function of a function, you should get the same thing as 2x minus 1, as 2 minus 1 gives you power 1. Okay, so with this, all you need to do now is to remember your quotient v du ds. Take the second variable, the denominator, differentiate the numerator, minus take the numerator, differentiate the denominator, all divided by the square of the denominator. So by so doing, we can have the y dx to be equals to v. So put in your v is x minus 1 all squared, du dx, which is 2, minus u is 2x minus 1, and we have dv dx, which is 2 into x minus 1, all divided by v squared. V is x minus 1 squared, and it's being squared again, so this is v all squared. Having substituted all the terms, parameters, the basic thing to do here is to keep simplifying. So if we look at the numerator, we can see the term x minus 1, and we have x minus 1 here. So that means we can factorize by simplifying it further. So this is going to be, if we take the x minus 1 out, so in these terms, I haven't taken x minus 1 from x minus 1 all squared, we'll be left with x minus 1, and we still have this 2, so we have this. Okay, so minus taking x minus 1, this out, we'll be left with 2 into 2x minus 1. So that is for the numerator, all divided by the denominator. Expanding this becomes x minus 1 power 2 multiplies power 2 to give you 4. Okay, so if you will simplify further, of course this x minus 1 here can take one of these out, it's going to remain 3, and we can have dy dx to be equals to, now in the numerator we can still expand where this 2 multiplies everything inside. That's going to give us 2x minus 2, and this minus 2 also multiplies this to give us minus 4x plus 2. So all over we are left with x minus 1 power 3 in the denominator, and with this 2x and minus 4x are identical, so that's going to give us minus 2x, and minus 2 plus 2 out of the same terms also it cancelled out, and we are left with this x minus 1 power 3. And so this is your final answer. There are lots of questions you can lay your hands upon to get a better understanding of differentiation of a quotient rule. I wish you guys the best. Remember to always lay your hands on question. You can rewind the video and try to solve it again. Look at it, check it out if you've made a mistake or not. I wish you all the best. Please kindly share and subscribe to my YouTube channel, Prof Dan Tutorials. Have a nice day and bye bye.